Very good evening, friends, and in this video I'm going to introduce you to Numpy libraries. Numpy libraries are the backbone of the machine learning and data analysis. Now you see in this diagram that NumPy, SciPy, Pandas, Mathlab, Scipit learns all are built. Now what is actually is NumPy? That NumPy is n-dimensional arrays. Now just look it as in this diagram, it has the one-dimensional, two-dimensional and three-dimensional arrays. All are the homogeneous data type and all the data types are same, and it has a lot of functions which makes the job easier. So now first I'll suggest that open your PyCharm and install this window, this pip install NumPy, and then we will be ready to work with it, because I believe in that. First you see what actually it is, then later we'll discuss what it was, like how it is made up of and how it underlying structure and the functions are. But first you know what actually it is, because I'm pretty sure that everyone might be knowing that what is the NumPy arrays and what are the normal arrays, because arrays are called as contiguous memory cells, and they have definitely in the C programming language also they have the same data types. So arrays are generally at the basic level, they are contiguous memory cells with the same name and they contain the same data type, means either all integer or float, all complex or boolean or whatever it is, but all of the same type. So now I have installed the pandas, also I have installed matplotlib. Now in this program I'll be using only NumPy. So first let me import NumPy, and that is import np as NumPy. So this way, friend, you can understand that how to import. If you do not know how to use the modules of the Python, you can watch my previous videos, and I have a playlist called as Learn Python. So now I have imported the NumPy, like the syntax goes like import NumPy as np, import matplotlib.pyplot as plt. I'm not going to use this, just I have written it because it has become a habit. Now let me create my first array, that is ar equal to np.array, and in the parenthesis I will write in box bracket 10 elements, all integer type 1 2 3 4. This is how I have created my first array, and its name is ar. So the first, just let me print it to check whether it has been initialized or not. So it's just like print ar, and now you see in the output window, here it is. So it has the 10 elements, so it should print the 10 elements. And now 1 2 3, this is how all these are the integer data type. Now if you want to see that what are the data types of these ones, then you can write ar.dtype. Now you check, yes friends, it is integer 32. So same way you can make the integer 32, integer 16, integer 8, integer 64, all these, so that you can have the different sizes of the variables, so that the different kind of accuracy can be achieved. It all depends on your mathematical knowledge and what exactly you are expecting from NumPy arrays. So this is integer 8, so it will take a lesser values. So because the memory management is also the task of the programmer, so you have to pay attention to it also. Otherwise, if you are working with the default values, there is no problem, but that will consume more memory. So now I just use int64. So this is np.int64. It has more precision, more accuracy, and the more size, where the larger number can be stored into this all integer. Same way we have the float 32, float 64, complex 64, complex 128, because Python have a complex number also as a variable. Now here I just work np.complex, and now you see that its size is how much, 128. You can also make it complex 64. So these are the sizes. Now other important features what the NumPy provides you is just to change the shape of the array and change the dimension of the array. Now here is printing the same thing into the complex form. That's what's representing the 1 plus 0j, 2 plus 0j, like that. This is the standard complex numbers. I pretty sure that you must be knowing about the complex number. So now, since this is the first introductory video about the numpys, and I have decided to make a 2-3 series, preferably 3 videos on this, because I don't want to make it unnecessarily long. Now here say ar dot size, so this way you can know the size, because since it is a 10 elements, so the size will be 10, and it's all 64 np complex. If you just take it, so it is 64, so it has around 8 just 64, so 8. So now you can say the 80 byte of contiguous memory have been assigned to it. Now if you want to change the shape of the array, then you can use ar dot shape, but first you need to know what is the shape. So ar dot shape will tell you what is the shape, and if you want to reshape it, then you have to call another functions called ar dot reshape. So now I'm working with the normal, so this is how, when the size is not mentioned properly, it will become 10 comma something is 10 elements, because exactly the later parts you have kept is empty. Inside the bracket, when you are making the multi-dimensional, then you can use brackets as well as the parentheses. So I'm just trying to make another multi-dimensional array, my friends, and here I have written 1 2 3 and then 2 4 5. So this is a 2-dimensional array. Now let's see. Just keep on eyes on the brackets and how the variables are initialized. So it should have a bracket inside a bracket, so the parenthesis, then the box, and inside the box we have the 2 boxes, each having 3 elements, 1 2 3 and 2 4 5. So now this becomes a 2-dimensional array. Look at the size, it says 2 by 3, means 2 boxes and each box contains 3 elements in it. This is how you can take it. So inside a box you have 2 boxes and each box contains 3 elements. Now I increase one more elements, so this becomes 2 by 4, and the number of boxes are remaining 2 only, but the number of elements in each boxes have become 4. It is not necessary that you can keep all the boxes at same size. You can just make, otherwise it will have the garbage value. This is called the, when the not properly formatted data types also there, when you are handling the data types, that we'll discuss later. Now I just try to introduce a better shape so that I can have the more elements into this. So I can, because the numpy arrays are n-dimensional arrays, and the main reason is that, you know, if you have studied about the tensors, then the tensors are the n-dimensional data sets, and here also we are just trying to achieve the same thing, because this numpy arrays are used in different fields like the SciPy, scikit-learn, and all other kind of libraries have been built up on them. And then the real life scenario, the real life data is quite different, and they have the different dimensions to it. That's why it has provided every possible features so that you can make a mathematical model of the real life things into numpy arrays. Now here I'm just trying to make a better like the many dimensional array. So now just pay attention to the parentheses and the commas and the brackets, because first you know about the size and the structure of the arrays, then you can you can make some operations on them and can get the derived result. But structure is the main and the very core concept of the numpy arrays, because this is a very fundamental array and its structure is very important. So just understand it. So I have written parentheses, then the box, and then another box, and then another box. Inside the boxes I have many boxes, and each box contains some different kind of elements into this. Now here it says it's showing that the 4 by 4, but actually it is because the number of brackets have not been placed properly. So let me rearrange so that you can understand it in the better way, and because if you do not understand the structure, you can never work with them. So here I just make certain changes. Let me make it more informative, just by adding more sense to my data, just by representation wise, definitely, because I'm not doing any mathematical operations on them. I'm just trying to show you, because many persons, they create one dimensional array and then they use the reshape functions to create the multi-dimensional arrays. But I am creating a multi-dimensional arrays, and later I'll change the shape and structure, because I think this is the way it should be looked at. Everyone have the different perspective, my friends, and you cannot deny that. There's no problem having the difference in the opinion, and having difference in the look and feel is actually the makes the whole world a prettier thing, right? So first I have a parenthesis, then a brackets, and then now see, now the order will be changed. So here it is, a three-dimensional arrays. So the each box have the four elements. That's why it is showing the thing like 3 rows and 4 elements in each. Now I introduce one more box into it so that you can see how actually it looks like. You can make because in the real life data types, I'm telling you, the image can also be broken down into the large number of the data types, three-dimensional actually, depending on their RGB values. So same way, sound, audios, videos, everything can be broken down into the numpy arrays with this or that data types. Sometimes because the numpy arrays use integer, float, complex, bool, string, and the other Python objects also as its data type, means it just handles everything. So yes, so now here I just try to change the shape of my array, because this array have 48 elements into this. So I create another array and with the name called br, where I write br equal to ar dot reshape. So the ar is my main array, and that will be reshaped according to the given dimensions. And then I'm writing 8 6 8 6 are 48, and it will be stored into br. So let me just check that what the br just print out. Now it has become, from the many dimensional, it has become the 8 by 6, like the 8 two-dimensional array. So now here you see each box have 6 elements in it, and there are 8 set of such boxes. Now if I change the whole structure as 48 by 1, or maybe something else, 48 by 1, so there are 40, it's become one-dimensional arrays. So if you write 1 by 48 and then the 48 by 1, it just gives you the idea of the row vector and the column vector, or the both are one-dimensional only, but the arrangement, because one becomes row wise and column wise, the axis only change. Because so here it says now it's 12 and 4. Now I have changed, so each box, 12 boxes, each containing 4 elements in it. Now if we reshape it further, so I mean to say that you can just make any kind of shape. So 6 4s are 24, 24 2s are 48, so 6 4 2. So the each box will have the 2 elements. There will be 4 boxes, and the containers having the 4 boxes 6. So the 6 main boxes containing 4 boxes, and each box have the 2 elements. Just look at it. This is how I feel. So you can say 6 rows, or you can say the 2 elements each, 4 boxes. Each box have the 4 set of values, and each set have the 2 elements in it. So if I change it further to 2 4 6, so each set will have the 6 elements. 4 such sets are there, and they make 2 final boxes. So this is how it just depends on you, how do you see, because you can take it as a 3 set of arrays like x axis, y axis, z axis, like that also. There is no problem with that. It just depends on how you look at the multi-dimensional arrays and what kind of knowledge you basically have. So when we'll do the better applications with the real-time data, then you can understand what actually it was. So this is how you can reshape, you can create any kind of data set with a different type of data, but in the numpy arrays it should be all same data type. So if you just go into the pandas, then you can find every data file have the different columns, but each column have the similar set of data. So now I'm using the numpy functions, and this is the br dot max, and this function will give you the maximum value of an element from the whole set of the data. Now I just change it to 14, so now the maximum number becomes 14. So same way you can find you can call the min function also, you can find the average function to find out the mean, you can find the standard deviation, you can find the variance. So different kind of functions are there, and in this short video I cannot use the all functions, or you can say the many of the functions. That's why I said I'll be using different maybe 2-3 videos just to explain you fully about the numpy arrays. So this is the minimum function, and then I change one element to -3, so that this, see now, see the minimum has become -3. It's so obvious, you can see it from the given data set only. Now if I want to call other functions, like to find out the other important features of the data, like br.sum function, so this function will give you the sum of all the elements. So now here let me see the sum. Yes, it's coming as 185. So it means all the 48 elements added together will give you the value, that is 185. Now it's mean is the average, so this is the sum total divided by number. So 185 divided by 48, and this will give you 3.65, and this is the average value of all the data stored into the given data sets called AR. AR and BR will have the same, because only the shape has been changed, but the value is not going to change. Now this is our variance. Variance is the square of the. So now friends, this is how the whole thing works, and just to keep on watching our videos and keep on growing with us. Thank you very much. Have a very nice time.